So in today's lesson, we're going to look at current and voltage. So there's going to be three learning objectives for the lesson. So the first one is know that current is the rate of flow of charge, so how fast the charge is moving in a circuit. Know that electrical current in a solid metal conductor is the flow of negatively charged electrons. And then know that voltage is the energy transferred per unit charge passed. And a volt is basically a joule per coulomb, so energy per charge. So these read equations as well will come in important when we're looking to calculate what charge is. So going back to static electricity, which some of you may have done for triple award content, electrical conductors and insulators. So a conductor of electricity allows electrons to flow easily, okay? Therefore, all metals are conductors. So if you look at the table, things like copper, steel, and mercury are very good conductors of electricity, whereas electrical insulators have a very high resistance. They kind of stop this electrical current from flowing. So again, looking at the table, substances like rubber, plastic, and even diamond, where all the electrons are kind of in the bonds, are very good insulators. Now, graphite, which is in your pencils, has one free electron which can move, therefore it is a good conductor of electricity. So in terms of electrical charge, which again was covered in the triple award content of electrical charge can either be positive or negative, and the reason why is all material is made of atoms, and atoms contain positive protons in the nucleus in the center and negative electrons which orbit that nucleus. And also the nucleus contains neutrons which have no electrical charge. Now, because the number of protons and electrons are the same number in an atom, that means that atoms have no overall electric charge. So in terms of current, the current is how fast this charge is moving. Okay, and the units for current are amperes. Okay, which is basically what happens is that the ampere represents how much charge, which is measured in coulombs, is passing by a particular point in a circuit every second. Okay, so an ampere, amps, is coulombs per second. In metallic conductors, like for example mercury in the previous slides, electrons carry negative charge on the negative side of a power supply around the circuit back into the positive part of a battery. So this is the charge current equation. The electrical charge, which is in coulombs, equals the current in amps times the time, or Q equals I times T. Now you can also, using this equation, find the current because that's the charge divided by unit time, and also the time, which is unit charge divided by the current. Okay, so that you can rearrange the equation to find out what you need for exam questions. I've even given you an equation pyramid which will help you with that. So finally, we look at voltage. So a battery gives electrical charge energy. Okay, so it transfers chemical energy in a battery into electrical energy. Now the volt of the battery is equal to the energy in joules provided by each of those charges, okay, of 1 coulomb that passes through that battery. Therefore, as you can see from the equation, voltage equals energy divided by charge, okay, joules divided by coulombs. So 1 volt, therefore, is equal to 1 joule per coulomb. Okay, so that's enough for today's lesson. Next lesson, we'll look more at circuits.